Today we'll be talking about the SVM assignment. We are required to develop a model using support vector machine which should correctly classify the handwritten digits based on the pixel values given as features. Each row in the dataset represents an image of a handwritten digit. Using some basic image processing, the images are converted into m by n pixels where m and n depend on the size and resolution of the original image. Now each pixel contains numeric values, with higher values denoting the presence of dense ink. In the pixels where nothing is written, the pixel value is 0. A pixel is called on if it contains a positive numeric value, else it is called off. Using these pixelated images, features are derived for each image. Now support vector machines are based on the concept of decision planes that define decision boundaries. A decision plane is one that separates a set of objects having different class memberships. There could be multiple lines or hyperplanes possible which perfectly separate two classes. But the best line is the one that maintains the largest possible equal distance from the nearest points of both the classes. So for the separator to be optimal, the margin or the distance of the nearest point to the separator should be maximum. This is called the maximal margin classifier. The support vector classifier essentially allows certain points to be deliberately misclassified. By doing this, it is able to classify most of the points correctly in the unseen data and is also more robust. Now, the support vector classifier is also called the soft margin classifier because instead of searching for the margin that exactly classifies each and every data point to the correct class, the soft margin classifier allows some observations to fall on the wrong side. The points that are close to the hyperplane are only considered for constructing the hyperplane, and they are called the support vectors. Now, SVM supports the following kernel types: linear, polynomial, radial basis function, and sigmoid. So, a linear kernel function is recommended when linear separation of data is straightforward. In other cases, one of the other functions should be used. Now, a grayscale image 100 by 100 pixels has about 10,000 dimensions. SVMs get us the best separating hyperplane and they are efficient in high dimensional spaces. Logistic regression assumes that the predictors aren't sufficient to determine the response variable, but determine a probability that it is a logistic function of a linear combination of them. So generally speaking, logistic regression is used for binary classification of data, whereas support vector machines are good for classifying data into multiple categories. Further, logistic regression works well with long data sets, which have a large number of records but few features, whereas SVMs can work equally well with long and wide data sets, which meaning they have large number of features with either modest or large number of records. Parameter sigma is used to control the amount of non-linearity in an SVM model. The higher the value of sigma, the more is the non-linearity introduced. So the lower the value, the lesser is the non-linearity. Apart from sigma, we have also got the hyperparameter C or the cost, soft margin constant. C is a regularization parameter that controls the trade-off between achieving a low training error and a low testing error. Cross-validation involves partitioning a sample of data into complementary subsets, performing the analysis on one subset called the training set, and validating the analysis on another subset called the validation set. Now, to reduce variability in most methods, multiple rounds of cross-validation are performed using different partitions, and the validation results are combined over the rounds to give an estimate of the model's predictive performance. So the goal of cross-validation basically is to test the model's ability to predict new data that was not used in estimating, in order to flag problems like overfitting and to give an insight on how the model will generalize to an independent data set. Now in this particular assignment, I've used the KSVM, RBF, SVM linear and SVM radial models. SVM radial gave the best training and test accuracy overall with a sigma of 0.0118 and C of 4. Specificity and sensitivity across the different classes was very good as well. Now typically if we need to go choose a particular model, we start with logistic regression. Using a logistic regression model serves two purposes. It acts as a baseline or a benchmark model and gives us an idea about the important variables. Then we can go for decision trees and compare their performance with the logistic regression model. If there is no significant improvement in the performance, then we just use the important variables drawn from the logistic regression model. Finally, if we still do not meet the performance requirements, we use support vector machines. But we have to keep in mind the time and resource constraints because it takes time to find an appropriate kernel for SVM. Also, they are computationally very expensive.